Today we'll talk about the second video in the LeetCode randomization series. Insert, delete, GetRandom 01, duplicates allowed. An extended problem from the one we just covered in the last video. In this question, almost everything remains the same, including the instructions and the constraints, except for the allowance of duplicate values. If you haven't watched the last video of LeetCode 380, please go take a look at it first. From the previous video of LeetCode 380, we already know that we can use a list and a dictionary to achieve insertion, removal, and random sampling in one time. The keys are to swap the to-be-removed element with the last element in the array to update the mapping information and to pop the last array element. However, the mapping between value and index would not work for duplicate values out of the box. So what should we do? An intuitive solution is to maintain a list of indexes for each value. In this way, there is no change to the insertion and random sampling parts. We only need to worry about the removal part. Now let's think about what happens when the to-be-removed element is swapped with the last array element. Let's say we still have an array here, and we still want to remove element A this time. The last element in the array is B, as usual. This time, A will actually have multiple indices. It's the same thing for B. Now, for the to-be-removed element A, because they are all the same values, I might just always want to remove the last one to prevent overheads. However, for the last element B, this guy might not map to the last element in the index array. It might actually be mapped to this one. But as long as we know which one it's mapping to, if we can somehow figure out this is actually mapping to this one, we can update this index with A's index value. In other words, in the duplicate allowed version, we not only need to maintain the value in the container, we also need to maintain where it locates. This one will be A, let's say this is A's fourth. I will put 4 here. And for B, let's say this is the B1. I'll put B1 here. So that when I decide to swap these two values, I will know B1, this value, needs to be overwritten with A's index here. And for A, we don't care. We just remove the last one in the index array. That's basically the idea we want to follow in the later implementation. Cool, now let's jump into it. Similar to LeetCode 380, we still need to have a container to keep the values. However, due to the existence of duplicates, we now also need to keep the insertion order of that value. So now we got a pair. It not only ensures that the pair is unique in the container, but also makes sure that each pair is traceable when we need to update the mapping information later. Self.container now becomes a list of tuple of integer, which is equal to empty list. The index by value now becomes indexes by value. Now it's a dictionary of integer to a list of integers. We can actually make it a default dictionary of list. For the insertion part, because we need to return whether the value has been in the list or not, I will introduce a Boolean variable at the beginning. I will say b not existed equals to length of self.indexes by value equals to 0. At the end, I will just return this value. Now, what should happen in the middle? I will first deal with the index by value. Self.indexes by value dot append length of self.image. Returningly, the container will also be updated with value and the insertion order of that value, which is length of self.indexes by value minus 1. And that's the end of insertion. How about removal? We first need to check if that value is removable. If there is no such value, then we cannot remove it. It's similar to the first check in the insertion function. We'll say if length of self.indexes by value is not 0, then we'll just return false because there's no way for you to remove it. Otherwise, we'll try to remove it and return true at the end. Okay, now we need to fill in the middle part. I first want to get the container index we want to remove. And that will be the indexes of that value. And since there are multiple values I can use, I might just want to use the most recent inserted one. How about the value we want to remove? The value itself is called last value. I also want to know the insertion order of the value. And all the information are actually inside the container -1. With this information, I will now need to update the indexes by value mapping. First, the indexes by value of the last value index will need to be updated with the container index. So the value at the end of a container will have its new location in the container. Correspondingly, the other guy, index by value will need to be popped because we decide to remove it. How about the container side? The container side is actually pretty straightforward. Self.container index will be replaced with the last element at the container. Now we will pop the last value in the container. And that's basically the update in the removal part. The GetRandom part is basically the same. We need to return self.container random int between 0 and length of the self.container -1. And now this is a pair, so we need to just get the first value. And that's the implementation. Let's try it out. Cool, now we passed the test case. Now let's do the summation. So you can see now it beats around 24% of the users. Even though the speed is not pretty ideal, it's because of the extra constants in the algorithm. But yeah, that's the end of this video. Thank you for watching.